Hello, my dear friends. Today I will discuss with you the JK flip-flop. Actually, JK is the modified form of the RS flip-flop. But in case of RS flip-flop, there was a limitation that when R and S both are equals to 1, then there was an illegal condition because in that case, RS flip-flop forces both Q and Q complement to the same logic level, to come on the same logic level, which is not possible because Q should be the complement of Q. Okay, that was an illegal condition. And this problem is overcome in case of the JK flip-flop, JK flip-flop accounts for this illegal input and therefore this is a more versatile circuits. Among these things, the flip-flop can be used to build counters, and counters can be used to count the number of positive triggers or the negative triggers of a clock. So there's the advantage of the JK flip-flop. Like there is no illegal condition, but instead of if instead that it comes to the toggling state. If G and K both are high, that will the flip-flop will toggle instead of going to illegal condition. So this is the basic circuit of the JK flip-flop, and there's a symbol. So let's look about the timing diagram. Here this is a clock of equal time periods going high and low. This is a J value. Okay, it is arbitrary. This is K value. It is again arbitrary. Now look, we have to concentrate on let that our JK flip-flop is positive triggered. When the this leading edge comes, positive rising edge comes, let's see what is J. J is high and K is low. If J is high, K is low, Q becomes high. Q goes to high. It goes from low level to high level. Q becomes high. If J is high, the Q becomes high when this leading edge comes, and then Q complement becomes that becomes low. Now you don't bother about in between. Now come to this edge, again the leading edge. Here is, look, J is low, K is high. If K is high, Q comes to low. Q goes to low state. Goes to low state, goes to low state now because of this leading edge, rising edge, and the same time Q complement, it goes to high. Okay, now don't bother about in between. Coming here, this leading edge, okay, this going high, this leading edge comes. Here J is low and K is high. J is low and K is high. Again the same, Q is low and Q complement is high. Now coming to this leading edge, okay, positive triggering edge. with the rising edge. Now J is high, K is high. So the flip-flop will toggle. That Q was low, now goes to high. Q complement was high, now goes to the low. Okay, toggles. Again, don't bother in between. Coming here, this is the leading edge, rising edge. Now again J is high, K is high. It again toggles. It goes from high to low state. It goes from low to high state. Okay, now coming here. Okay, the leading edge, rising edge. Here J is 1, K is 1. Again toggles. Q goes from low to high. Q complement goes from high to low. Okay, this is the what is the relation between J, K and Q with respect to clock. Okay, thank you. Hello, my dear. J equals to 0, K equals to 0. Let the previous state Q equals to 1 and Q complement equals to 0. Clock is high. The whole line is at low potential, 0 at here, and gate gives 0. 1 comes here. This AND gate output also 0. The whole line is at 1. This NOR gate gives 0 output. The whole line is at 0. 0, 0 is 1. So this is a stable state 0, 1. Okay. If J is 0, K is 0, the previous state will exist. The last state, whatever it is. If 0, 1 last state, then it exists as it is, no change. Let's again J is equals to 0 and K equals to 0 in the previous state. Now, let we alter the previous state. Q complement 1, Q 0. This 1 comes here. So this is 0 because one of the AND gate is 0. This is also 0. The whole line is 1, 1, 0 is 0. This whole line is 0, 0, 0 is 1. This is again a stable state. So if the previous state is 1, 0, it exists as it is, no change. So J equals to 0, K equals to 0. New state is let Qn plus 1 and previous state as Qn because Qn is previous and Qn plus 1 is new. So new state will be the previous state. Now let's think about 0, 1 and clock is high. And previous state is Q is 0 and Q complement is 1. This 1 comes here. This 0 comes here. So 1, 0 means 0. This 0, 1 clock is high. Even then the output is 0. So 1 is here. 1, 0 is 0. 0 comes here. 0, 0 is 1. So this is again a stable state. If the J is equals to 0, then Q will be 0 stable. Now let's set 0 and 1. Now here let Q is 1 and Q complement as 0 and clock is high. Clock remain high for a fraction of second, Then 1 is here, 1 comes here, and 0 is here, 0 comes here. 0, this is 1. So what happened? The 0 comes here, this is 1. Okay, 0, 1 is, look about the NOR gate. 0, 1 is what? 0. So 1, 0 comes here, 0, 0 is 1, 1 comes here. So 1 comes here again, 1, 1 is, 0. So this is 1, this is 0. So, like if J is 0 and K is 1, if whatever the previous state, it alters and it forces Q to become 0. Okay. This is very important lines to understand. Read carefully the lines. So now let's look about j equals to 1 and k equals to 0. Let previous state has, previous state has 0 and 1, q0, okay. 1 comes here, 1 is 1 clock, 1, 0, this is 0. Right, this is for a fraction of second it introduces its changes. So 1 is here 0, 0 is here, 0 1 is 0 1 is 0, 0 comes here, 0 0 is 1, 1 comes here. So this is 1 now, 1 comes here, 1 1 is 0. So 0 it becomes 0 1. So if j equals to 1, it forces q equals to 1 always. If j equals to 1, it forces q to become 1. Now if q is 1 and q complement as 0 and input are same, j1 and k0. Okay, this line is completed. Okay, 0 comes here, clock is high, output is 0. This is 0 and AND gate gives 0. So this is, like 0, 1 is here, 0, 1 is 0, 0, 0 is 1. Okay, this is stable state. So if j is 1, k is 0, it forces q to become 1 always. That's a set state. Now let's j equals to 1 and k equals to 1. When the first positive triggering pulse comes, like the first positive triggering pulse comes, j equals to 1 and k equals to 1. Let previous state is q equals to 0 and q complement as 1. Okay, so this is completed. So 1 comes here, this is 1 1 output, 0 is here and it gives 0. So this line at 1, this gives 0 0 at here, that becomes 0. So 0 comes here, 0 0 is 1, 1 comes here. Okay, the 1 comes here, 1 1 is 0. So this is again a stable state, 0 1. So what was the previous state? It is toggled. Now it alters, now changes. Okay, previous state alters. Now second triggering pulse comes, now second triggering pulse comes. What happens? Now comes second pulse. So this comes 0 is here, this is 1 comes here, and this AND gate gives 0 and the AND gate gives 1 and 0 at here, this 0 comes here, so output is 0, this is 0 comes here, 0 0 is 1 comes here, so this is 1, the 1 comes here, 1 1 is 0. So now there's again a stable state, 1 0, it is again toggle. So when second pulse comes, state becomes stable but toggles, it alters again. Now when the third pulse comes, triggering pulse comes, what happens? When third triggering pulse comes again, it toggles. It will force now q to 1 and q bar to q complement to 0. When fourth comes, it forces q to 0 and q complement as 1. It again. So if each time pulse comes, it toggles. So this is the very beauty of the circuit. Now j equals to 1, k equals to 1. It is not an illegal. So 0 0 means last state exists. Whatever it is, 1 exists, and 1 0 is set, 1 1 is toggle. This is toggling state. Okay.